Of it. This is Duda and Hart, pattern classification. This came out last week. He is an expert on HAL, the computer, and wrote a book about it. I forget what its name is.
HAL's Legacy.
HAL's Legacy. And he is a man of 1,000 talents. And it's a pleasure to introduce David Stork.
Thank you very much. It's a great pleasure to be here. Seeing a video camera reminds me, just yesterday I was filming my PBS documentary. Tonight I fly back to Boston to film more. And so I'm normally doing exactly this and looking really focused, and I'm talking to one person, and I'm really got to get anything right, and then the guy says, go back and do it again, and I have to stop. So talking to a camera is very different from giving a lecture, and today I'm here to give a lecture. I want to talk about the Open Mind Initiative, and first thing I should thank Fred and Bill and everyone who was instrumental in having me here. It's a great pleasure to be at Hopkins. I grew up in Maryland, a couple miles further south, outside of Washington, D.C. I knew Hopkins well years ago, haven't been back for a long time. It's a great pleasure to be here. But I want to talk about the Open Mind Initiative, and the subtitle is Extending Open Source for Collecting Data from Non-Experts for Intelligent Software. So what's that mean? Here's the outline. I hope everybody can see this reasonably well. So first I'll start with a one-sentence description of Open Mind just to get you in the ballpark what I'll be talking about. Then some of the background, some of the forces I think that are leading to the Open Mind Initiative. And then I'll talk about the initiative itself in a little more detail about how it works. And then some of the projects. We have 3 projects ongoing now in the initiative, and then I'll talk about several possible projects. Then this is closest to my intellectual heart, unsolved problems in machine learning that are brought to bear, that are brought to the front by the Open Mind Initiative. Some of you may want to do dissertations on it. And then some conclusions. Well, the Open Mind Initiative is a collaborative framework based on traditional open source software methodology for developing intelligent software. I won't define intelligent here, but it'll become clear, I think, as we go along. That consists of 3 main components. Domain experts, they will provide algorithms. A domain expert might be someone who knows about speech recognition, or optical character recognition, or common sense reasoning, or geological database mining, things like this. There might be university professors or established experts, PhD level people. Second component participants are tool developers. They provide the software infrastructure and tools. People from the Linux community who might not know about speech recognition, but they know about databases and security and backups and mirroring sites on the web. And the third component is the most novel, the most interesting to me. Non-expert netizens. If you can think of a better name than that, let me know. We've gone through about 10. Naive subjects does not work, by the way. That's a really bad phrase. But non-expert netizens, they are going to provide data over the internet for these systems. Now let me talk about some of the trends that are leading to the Open Mind Initiative. And the first involve electronic communities. Having the web allows large numbers of people to collaborate on bigger projects. And perhaps you're familiar with the Free Software Foundation and GNU tools and GCC and things like this, SendMail, Emacs, and Apache, all these software systems that were developed through open source or free software, where people willingly contribute, they don't get paid for it, and you release software often and early, and it gets revised and improved. Perhaps the most famous example is the Linux operating system. When I made this slide, there were 10 million lines of code. There were 30 million seats, 30 million desktop machines that were using it. The doubling time around a little while ago was about 6 months. That is, the number of people using it doubled every 6 months or so. And an interesting fact is almost 100,000 people have contributed to the Linux operating system. Device drivers, file management systems, and so forth, bug reports. These people all contribute, and no one gets paid. There's no central company that owns Linux. Certainly there are companies like Red Hat Linux that market it and sell it and print it to disks and so forth. If you were to value or evaluate the Linux operating system at commercial costs, $100 per line of fielded operating system software, Linux would be the third largest software company in the world after Microsoft and Oracle. There's no central company. This is pretty remarkable. Another background stage is the NuHu Open Web Directory. The basic notion here is that you would have people, we all know web searching is poor and can be improved greatly. One way is to have actual people go to websites and write smarter keywords than those that can be extracted directly from the text on those pages. And this is the NuHu, based on Yahoo, just the name is based on Yahoo, but the NuHu Open Web Directory. And a while ago, there were 1.5 million websites that had been visited by people. There are 22,000 editors and 218,000 categories. So smart people actually look, or average people look at these websites and give better keywords so that you have improved search. And the Infomedia project, this is an open source encyclopedia, and there's several different versions, but the basic notion is you're interested in Frisbee, so you write a 3-paragraph article about Frisbee and post it. You're interested in football, and you would write your article, and if someone wants to add to it or subtract from it, suggest changes and so forth, you would all collaborate to build this kind of encyclopedia through this open source method, this open approach. Now, let me put this in a broader perspective. In 1978, you might have on the order of 100 programmers, and out several years later comes the Emacs text editing system. In 1990, you might have 100,000, call them hackers, people who know how to program, surely. And 5, 6 years later, out comes Linux. And of course, it keeps coming out every couple months in a new release and so forth. In 1995, you might have 100 or 1 million people who know HTML and have common sense about the world and know about topics. They don't know how to program. They don't necessarily have to know how to program. And out comes this NuHu web directory. And then you have what we're predicting, what we're starting, what the Open Mind Initiative is all about, is getting a large number of netizens. Who knows how large that number may be. And out several years from now will pop Open Mind software. The two trends that are so important here are that the number of collaborators per project increases per time. Start out as 100, 10 to the 5th, 10 to the 6th, and larger. It keeps getting more and more people that can work together based on having the infrastructure of the internet. And the average collaborator expertise level decreases. Think of the people who contributed to Emacs, especially back in 1978 before you had all these great software tools. Then you get the hackers. Then you get people who just know HTML. And now you have netizens who just know how to point and click and shop on Amazon.com. We're trying to capture the information from the large numbers of average people. So those are the two trends that underlie the Open Mind project, Open Mind Initiative. Well, I've been working on pattern recognition for a long time, and that book is just part of my output. But one thing you learn when you build a recognizer, be it handwriting recognizer or whatever, is that you have theory, that might be maximum likelihood or Bayesian estimation, something like that. You have a model, I'm going to have a mixture of Gaussians, I'm going to have a hidden Markov model, whatever it might be, and you have data. I would say for a large number of problems, theory is excellent. We have very good fundamental theory for estimating parameters in general classes of models. Of course, models depend upon the particular problem, whether you're doing handwriting recognition or speech or whatever. But for data, there's never enough. Or the group with the most data wins. And there are plenty of examples. You each probably have 10 from speech and language where you could give examples. From handwriting recognition, there was an important paper by Ho and Baird that took very simple classifier techniques, nearest neighbor, decision trees, neural networks, and just trained them all three with large amounts of data. And after you got to 3 million characters, they all performed the same. So whoever has the most data wins. And there are plenty of examples of companies like CARE Corporation, one of the leading handwriting and typed OCR, optical character recognition companies. They've been in business for about 15 years. And from the beginning, they've had 2 full-time people whose sole job was to take in characters and type them into a computer. That's a B, that's a K, that's an N, or just typing things and so forth, and having these scanned. And that database is one of their most valuable corporate assets. It's more important than the neural networks that they use. It's more important than the hidden Markov model. It's more important than any of the other things. And they would never sell that. I mean, that's their corporate assets. So getting lots of data is crucial. I think I'm preaching to the converted, but that's what underlies the Open Mind Initiative. Now let me talk in a little more detail about the initiative and how it works. Again, I talked about the domain experts. They contribute fundamental algorithms like hidden Markov models, like decision trees, whatever it might be. They also contribute things like process control. Only they will know what is a true outlier for their problem domain, what makes sense as an input pattern or a possible response that we're going to be getting from netizens. I think that'll become clearer as I go on, though. And the tool developers will provide the software infrastructure and tools and backups and mirroring and databases and security and so forth. And the netizens are going to provide the raw data and perhaps low-level bug reports as that will become clear. So let me now talk about each of these in turn. The domain experts. So they'll provide algorithms, for instance, grammatical inference or hidden Markov models or neural nets or whatever it is that they feel is the right recognition. I'm going to talk about recognition, and we'll come back to things like bracketing and other things that you know more about than I do. But it's easiest to understand the initiative in terms of pattern recognition, taking in a pattern, trying to classify it using some sort of model that gets trained with lots of data. They'll also provide process control and data truthing. So, for instance, methods for detecting outliers for review or rejection. So if we're trying to learn some properties of a distribution, we might get some mean and standard deviation, and the domain expert says anything 6 standard deviations away, we can neglect, we can discard. Or techniques such as data voting, and I'm going to come back to this, but suppose we're going to be developing a handwriting recognition system, and we present onto web browsers of the netizens handwritten characters for them to identify. That's a B, that's a K, and so forth. Well, one technique to ensure the quality of the data is to present the exact same pattern to several people, chosen randomly and independently, and only accept their data if all 3, say if it's 3, if all 3 agree. This is a K, this is a K, this is a K. Yeah, it's probably a K, I'll take it. Well, that's a technique called data voting, very, very simple one. And there are interesting problems. How many people should I choose before I will accept it as high quality data? Can I even accept it if it might even be flawed and so forth? I'll come back to that. Or catch trials. You're contributing data again and again and again, and I want to know how reliable he is. Every once in a while, I put in an absolutely perfectly crisp 4. One that I've known from before is a 4, one that our classifier classifies as a 4 with very high confidence. So I know it's a 4, and I put it to him. If he says it's a 5 or a 7 or a 9 or something else, I know he's unreliable, and I may throw out all his previous data, just his last K contributions and so forth. So this is the kind of higher level stuff where you maybe should know a little bit about probability and statistics and Gaussian distributions and so forth before you're going to contribute. This is a different person from someone who's going to contribute Linux code, for instance. There's also, and I'll come back to some of these other things like signal detection theory and bias avoidance and things. But there's a trend to publish data and algorithms on the web. More and more stuff is being on the web, especially in my field of pattern recognition and machine learning. You put the algorithm out there, you have a data set that's out there. Try your algorithm on this and see how well it compares and so forth. And I think the Open Mind Initiative just extends that trend of allowing things to be more public and open on the internet. Now, for the tool and infrastructure developers, their guiding principle, the overriding principle that's leading their work is to get the maximum information from the netizens for minimum netizen effort. We want to make it easy for people to contribute data, and when they do contribute data, get the most information from it. For instance, a very simple technique is learning with queries, where you present informative patterns to the netizen to label. So for instance, if we were doing differences between 4s and 9s, I don't give you an absolutely perfectly crisp 4 and say, please tell me what that is, because I know when you tell me it's a 4, I haven't learned much. I go near the decision boundary where the classifier is least sure, and I take a pattern from around there, or I generate a pattern that's near there, and present that to you. When you label that, I get the classifier gets the most information. So for one click of the netizen, I get more information if I use learning with queries. So you also want to make it easy and fast for contributors, so we might want to cache patterns on their local machine and so forth. Let me skip establishing communities. And also, but go to rewarding contributors. We want to be able to give people something back for contributing. That which leads us to the netizens themselves. And the first thing you're asking is, why would anyone want to contribute data to the Open Mind Initiative? What incentives? Why would anybody want to do this? Well, I think there are a lot of reasons, and let me go through some of them. So again, netizens are just your grandmother in Duluth, your 19-year-old friend down the hall, your 7-year-old son, whatever it might be. Anyone who can point and click on the web, who knows how to read, has common sense about the world, and so forth. Well, what are some of the motivations for someone to contribute? Well, one is they get the benefits in the used system. So they'll be able to download for free a handwriting recognizer or a speech production system, whatever it might be, whatever the individual project might be. Another motivation would be fun and games. I estimate that 10 trillion mouse clicks have been wasted on solitaire in the United States. That's a heap load of clicks. Imagine we could make a fun game, again with the optical character recognition example, where people would play it and we'd be learning in the background. A shoot 'em up game where you have to shoot at the handwritten 4s but not at the 9s. And here they come, here they're just coming at you, and you go click, not click, 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 and so forth. And in the background, we're just learning all the time. This person thinks this is a 4, this is a 9, and so forth. So once you can get a fun game, you can get a lot of clicks. Or Dungeons and Dragons. Some of you are familiar with that. But imagine the goal is to go through a castle to the human king and avoid going through the castle to the robot king. And every room you come into has swords and potions to drink and things like this. And there are 2 paragraphs that tell you what to do. They're both generated by machine text generation algorithms with different parameters. And all you do is click on the one that seems most human. You don't have to know anything about linguistics. You don't have to know anything about comma splices, verb dependency, dependencies of one word upon another, or grammar, or past tense, or anything like that. Something about this paragraph seems more human, natural to me, and you click on that one. If we can get, I don't know, 1 million, maybe you have better estimates of how many samples of that kind of feedback we would need in order to train and tune these parameters so as to generate more natural sounding text in a chatbot, say, we'd be able to get that kind of data. Another thing is recognition. People love to see their name in lights. If you go into any arcade game in the country, you'll see Bill, 14 million points on this game. Sue, 13 million points, and so forth. People just like to see their names, especially the netizens who don't have their own websites, perhaps, and so forth, just to say you've contributed so much data and someone else has contributed less, and so forth. That's one of the big motivations behind the SETI at Home project, where you donate not your mental cycles, but your computer cycles. My machine has looked through 18,000 hours of SETI radio telescope data to look for little green men. So people like that. Another is general interest. People like to see how a project improves. Imagine we're doing optical character recognition, and we can plot versus time the accuracy. And so here's, here's 100% on some database, and here's 97, and this might be, I don't know, Microsoft, some company. And here's what ours is, Open Minds is at this time, and here's what it is at this time, and here's what it is at this time, and here's what it is this time. Do you think people are going to stop here? I think not. I think they're going to keep contributing more data, because this is not just time, this is how much data has been contributed. And people are really going to want to see this happen. And so they're going to see the, they're going to want to contribute and watch the system improve. That's a very simple notion of watching it improve and seeing the progress of the system. A more subtle and frankly more interesting one would arise in trying to get common sense into computers. Common sense is a profoundly hard problem to try and get machines to have. Here's a pen, it's made out of metal. I turn it upside down, it's still metal. Everybody knows that. Here's a bottle of orange juice. If I turn it upside down, I won't, but if I did, it's no longer filled with orange juice. Everybody knows that, but no machine does, right? Why would a machine know this? Or if you're dead, you stay dead. Or, animals run faster forward than sideways. There's all this common sense we have that no one sat down and taught you. Your mother never said, by the way, when you're dead, you stay dead. I mean, no one. We want to have machines to have that. Well, I was just down at the Psych project, or PsyCorp, down in Austin a week and a half ago. And they've been working on this problem for 17 years. And I won't go through the details of it, but one aspect of it is that experts, knowledge engineers, put in information, and the system reasons about it and tries to find inconsistencies or ambiguities within the whole data set, which it then presents as questions to the users the next morning. Is every husband a father? It just doesn't know that, and you have to answer yes or no and so forth, and it gets recompiled. Early on, the kinds of questions it comes back with are really stupid. They're really dumb. They just show it doesn't understand much at all. But as it gets more and more data, it gets more and more subtle and shows a little more understanding. And if you ever watch the cognitive development of a child, it's really fascinating to watch him or her figure out one of these things. And I think the same thing can happen with Open Mind Common Sense, where you'd have a list of the kinds of questions it did 6 months ago. Look how silly it was. 3 months ago, today. I wonder what kind of questions it'll have next month if we keep giving it more data. So that kind of motivation for people to see it improve, I think will drive it. Altruism and philanthropy. I gave a version of this talk at the Stern School of Business in New York City, and a guy stood up in the back and said, there is no altruism. Let me explain what I mean. Think of the OED, the Oxford English Dictionary. There, the editors in London would put in the London newspapers requests for information. Please help us find the earliest example of the word house. And people would go back to their books and look through and send it in. Of course, that data had to be checked by the editors. But the people who contributed it were not paid. They didn't get their name in the back. They just liked it. They liked to be part of this and contribute. Call that altruism. That's what I call altruism or philanthropy. And that's what I mean by it. People want to do it because they just like the field and the topic. Or Audubon bird counts. If you like to watch birds every Christmas day, you go out and you count how many cardinals are out there and you send it in and so forth. There are a lot of people who just contribute. Another is education. Another motivation is education. Imagine we do bracketing. Now, I'm no expert in bracketing, but imagine we go to every 11th grade English class in the country and present them over the web, 1,000 sentences, either sampled from New York Times or Wall Street Journal or scanned documents or somehow. And we ask people to label the parts of speech. And we we present the same sentence to several schools independently to make sure that they get, we only accept it if they agree. But if we could get, 1 million, 10 million, some large number of sentences with proper bracketing, I think that would be educational to the students. Gosh, this is interesting. How can I do this and machines not? And they would also get interested in the kinds of fields you're working in now. Another motivation is lotteries and gifts and frequent flyer miles and e-coupons and things like this. MIT Press was gracious enough to give the Open Mind Initiative 6,000 books to give out as computer books to give out as incentives to contributors to Open Mind. That's a cube, 2 meters on a side, 12 tons. We still haven't found a place to put them. Nevertheless, I think once this gets going, we'll have companies who would like to get their name associated with it, get new traffic, get new people to come to their sites and be more liable to use American Airlines frequent flyers or whatever. Money is a terrible motivator, and I won't go into it now, but you can ask me in the question and answer period. It's more subtle than just saying money is venal. I would also point out there are 1.5 million inmates in the United States with a lot of time on their hands, and 1 million people in nursing homes who might even be able to contribute. So now let me talk about the generic project structure. Again, I've referred to handwriting recognition, but this will make it a little bit clearer. So you take a recognizer off the shelf, out of the, the standard literature, and you present isolated characters on the netizens' browsers, and you may want to use learning with queries. And so here's the simple architecture. Here's the Open Mind host, and you present on each web browser anyone who comes in either a 4 or a 9, and it's of course handwritten, came from being scanned, and just buttons. Click on this as a 4 or a 9, and that data gets brought back here, and you could use learning with queries and other things. They could be scanned from lots of documents, or they could be, that's generally the best way to do it. There are lots of databases of unlabeled data sets. Or better, could be speech, where you would play over utterances or words or maybe whole sentences and ask people to transcribe them if you're doing speech. I'll come back to specific projects in a moment, but let me compare and contrast Open Mind to traditional open source. Think of Linux. In open source, you have no netizens, no non-experts. Everybody knows how to program, whereas in Open Mind, the netizens are absolutely crucial. In open source, it's expert knowledge that you're pooling. Think of the people who contributed to C++ Filt or GDBM, something like that. This is very expert knowledge. You have to go to school or program for a long time to be able to do it. Whereas in Open Mind, the kind of knowledge you're harvesting is informal knowledge, the kind of knowledge anyone who can read and hear and has common sense about the world has. In open source, machine learning is absolutely irrelevant. It is never used. Whereas in Open Mind, machine learning and pattern recognition is the way you extract out the information from this large set of contributed information. In open source, the web infrastructure is useful, but I wouldn't say it's essential. The Free Software Foundation worked fine before the web was up. Whereas in Open Mind, the web infrastructure is absolutely essential. It's the lowered cost that allows this data to be collected. In open source, most of the work is directly on the final software. If you're contributing to Linux, your actual device driver, your actual keystrokes are going to appear in the Linux operating system. Whereas in Open Mind, most of the work is on the infrastructure and data collection and so forth, rather than the final shipped software, which comes through the learning. I would call open source a hacker culture. If you've got a better word from hacker, let me know. Whereas for Open Mind, it's a larger culture, and call it a netizen or business culture. In open source, the software gets released, but in Open Mind, not only the software, but the data itself can be released. Anyone else can use that data since it was openly contributed. Now let me compare and contrast data mining to Open Mind. In data mining, the type of data may not be available for the project desired. Suppose you wanted to develop an optical character recognition system, and I said you have all the compute power you have, all the time you want, all the money. Do it by harvesting data over the web. You couldn't do it. The data just doesn't exist, those handwritten characters. Whereas in Open Mind, the data gets tailored to the project desired. So you would generate sentences. You would generate your game or whatever it is. In data mining, there are no interactive queries. You may have a large database and have lots of information, but that typically means slower learning. Whereas in Open Mind, you have interactive queries. You can focus in on those parts of the feature space, if you will, that are ambiguous, so that when someone labels it, you get more information back. That allows ambiguities more likely to be resolved if they might not have been resolved in pure data mining. There's a relatively fixed amount of data in data mining. It might be large, of course, but in Open Mind, new data may be encouraged. You may be encouraging people to give more data than you had before by seeing things like this. Let me skip one. In data mining, there's little or no netizen support. In fact, there's often netizen hostility. People don't want someone else to be mining their data about themselves. Oh, what kind of car do you drive? How many kids do you have? Where do you vacation? Whereas in Open Mind, only people who willingly want to contribute are participating. We're not trying to go behind their backs and steal their data or anything like that. Also, the open framework in the Open Mind Initiative allows cross-project integration. So imagine you have some form of linguistic constraints through a project, an Open Mind linguistics project, yet to be described, that could somehow be useful for an Open Mind optical character recognition project. So you have a handwritten sentence, and this word is ambiguous, but from linguistic constraints, it's got to be a verb, and that may help you to get better accuracy on it. Or you could use the Open Mind speech system as a front end for a game. So as you're talking to your game, you're playing with your game, and every time you're saying, go left, go right, go left, go right, for this thing that's going through a maze, it's learning in the background how to say go left and go right. That could be useful. Or go, stop, or yes, no. If we had, I don't know, 10 million examples of people saying go and stop or yes and no, I think you'd do better. You do pretty well as a recognizer for just those two words. Or use of, this is way in the distance, Open Mind common sense. It could be useful for Open Mind language understanding or topic identification, things like this. Now let me talk about the Open Mind projects that are underway. One of them is Open Mind handwriting. And here's a screenshot. The idea is you have a very large number of scanned, handwritten words that have been pre-segmented out by a semi-automatic system. And the question is at the word level. And now the question is recognize the individual letters. And the netizen comes up and clicks here, click, and then clicks here. And this automatically turns one color. And you get to type in what letter this is. This is an M. Click. This is an O. It doesn't look like an O very well, does it? But it is an O. And not only are you learning, now getting the patterns for what it is an O is, but you're learning it in context. This is how this writer puts an O after an M. We may have this writers after a T, and it might be different or something like this. So you're getting bigram, trigram, and other kinds of information. This is being done at the University of Nijmegen in the Netherlands. And the segmentation data capture software is all up, and the transcription software, how you enter data and so forth. We have this large set of unlabeled characters and words where it works in a small intranet. It is not yet ready for millions of hits. There's a lot of software engineering that happens when 1,000 people try and access a website in a minute, and we're not there yet. So there's a lot of bulletproofing, as we call it, has to be done on that. There is here's the kind of handwriting data. They've got large amounts of, came through the European Union. Britain has a clear strategy for eradicating whatever. Now, remember the guiding principle for the infrastructure developers is to make it easy for the netizens to contribute data. So we can imagine, we're not there yet, but we can imagine having a transcription typed underneath each word and some sort of confidence level, the classifier's confidence level represented in color on each word. So if it gets Britain, if it's really sure this is Britain, it's right in this dictionary, it recognizes each letter and so forth, this might be in blue. Whereas this word, I don't know, is this dear or clear? I'm not sure. It might be printed in red. And that makes it easy for the netizen to say, oh, this is a word that might have to be fixed. Let me just go here. And underneath, it might be a pull-down menu, clear, dear, beer, I don't know, whatever it is. And then just make it quick and easy for the netizen to contribute that kind of data. There's a nascent fledgling Open Mind speech recognition project being done at the University of Sherbrooke. A couple of graduate students, they're using the Sphinx 2 open source speech recognition system as their fundamental engine, and they want to capture the Linux community, so they want to have Linux commands so you can speak to your machine and program it. They've got a lot of generic tools. I won't go through all the details here. It's really just getting going, but we'll see how that goes. Here's a screen dump of being able to put together filters and things like that. Nothing particularly sophisticated yet. One of the more interesting and frankly our furthest along project is a common sense project being done at the MIT Media Lab. And the netizens contribute simple assertions. Grass is green. here we were talking about having assertions related to computers, try and focus on common sense about computers. First releases are generally buggy. I mean, show me a novel, show me a textbook that says that. I mean, we all know that kind of thing. Or a mouse is an interface, things like this. What we're finding, though, is that the inferencing rules are very hard for netizens to contribute. But there probably aren't that many of them. And so the graduate students up there are putting a lot of these things in by hand. And now let me talk about several possible projects. I just want to whet your appetite, fuel your imagination, whatever. Imagine an open mind text-to-speech system. So the user, the netizen, would download for free the text-to-speech generator on their desktops and type in their favorite sentences or play their favorite paragraphs, whatever it is they want to use. And the system speaks those back with two systems with different sets of parameters, different prosody, different stress, different whatever, different parameters. And all you do is you say, I like the first one better, or I like the second one better. If you get lots and lots of data on a particular person, you'll be able to learn their preferences, and that will train the parameters in the text-to-speech system. So the netizen chooses the best model, and the data gets collected at the Open Mind host. I know what you're thinking. The question is, what if he likes something with a such-and-so accent, and he likes something with a different accent? Well, I'll come back to that issue of individual differences later. An open mind spam filter. I think it would be very motivated people to contribute, when you spam, unwanted email, to be able to automatically forward this and say, this is spam, and send this to the Open Mind spam site and Open Mind non-spam site, and get large databases of things that the users feel is spam and non-spam. Spam is, of course, technically known as an arms race, where the spam companies send stuff. You get a spam filter that can somehow keep that out, and then it gets better, and then so forth. They keep getting higher and higher. Problem with an arms race is if you don't fight, you never win. And having lots of people contributing through an Open Mind spam filter, I think will do much better. And someday, maybe it's a long way away, we get rudimentary notions of understanding when we have this large database. Simple features, by the way, that indicate spam, if you can write this up in your own shell script if you want. Presence of exclamation points, dollar signs, the word free. And here's an interesting feature. The maximum length of sentences in all caps, or the average length of sentences that are in all caps. Those are highly indicative of spam. So someday we would like to have something that understands the rudimentary notions of this is trying to get me to buy something, this is trying to get me to contribute something, to whatever, to have a more improved spam filter. Or an Open Mind chatbot, something that can, you're all familiar with ELIZA, Joe Weizenbaum's system that allows you to ask questions and get simple answers. So imagine netizens answer questions online or complete sentences, and that kind of data then goes back to make a chatbot. Turns out this approach has been done by a graduate student in Australia. He had the data from a mere 250 netizens, and he won the Loebner Prize. This is this fake Turing test that's done at the Boston Computer Museum, where people can ask it questions and you have to guess how human-like is it. And his system did best. I think through Open Mind we could get 1 million people. I think it would be fun. People would want to do that. And also to know that, gosh, next month is the Loebner Prize. Let's give it more data. Let's see where it's, so forth. Here's something very close to my heart. Open Mind object recognition, which is a very, very hard problem. But imagine once people have more digital cameras and they're less expensive and people are taking lots and lots of pictures, they may want to contribute those to an Open Mind object recognition database. Just to have a photograph of your cat sitting with the label cat sitting is very, very useful. If you were to have 1 million pictures of cats sitting, and I don't think 1 million is an outrageous number, by the way. Think of all the cat lovers and all the pictures that are on the web. Or horse sitting, and you have this kind of a database that would allow someone who has simple geometric models of animals and the possible joint angles and so forth to do a recognition that you would get refined and change parameters on based on lots and lots of data. I won't go through all the details there. Now, let me talk about some of the problems in machine learning that are brought to the fore by the Open Mind. Our goal is, of course, to get the optimal classifier or AI system or whatever the particular task is. And this differs from traditional learning and noise for several reasons. But one is that we can use interactive learning, and we also want to reward good data and punish bad data. So as you're giving me data, I want to encourage those people who are giving me good data, give them your frequent flyer miles and compact discs. And for the people who are giving me bad data, let him know immediately, I know that you're trying to fake me out. I know you're just trying to get those frequent flyer miles and you're just clicking away, or you have a little chatbot, a little robot system typing away. I want you to know that I got you, I figured you out as soon as possible. So that's a little bit different. So we also want to learn the reliability of netizens. We want to know that he's unreliable and you're very reliable. In case you both try and classify a single pattern and disagree, I know to listen to him and not to you. This is really now a mixture, a very interesting mixture of game theory, decision theory, machine learning, and pattern recognition. It's game theory because he has a goal. He wants to get his frequent flyer miles or his name and lights or whatever his goal. I want to get my classifier. So we each have, and we're in some sense competing and collaborating. There's decision theory in that rather than just trying to make the best classifier, I'm trying to make the best decision on what pattern to present to improve my classifier. So there's a cost associated with presenting any particular pattern. There's machine learning because, of course, I'm learning all these things in the background. I'm trying to build my classifier. And, of course, there's pattern recognition if, indeed, that's the class of problems you're trying to solve. Let me give you a very simple system that my graduate student at Stanford did on a weekend, basically. It's not his thesis research, but it'll give you an idea of some interesting approaches that come in Open Mind Initiative. And perhaps anyone who's taken AI has programmed up a game called Animals. The netizen comes to the screen with an animal in mind. Oh, horse. And the machine tries to guess it by a series of yes-no questions. Does it have 2 legs? Yes or no. Can it swim? Yes or no, and so forth. And at the end, the computer makes a guess. I think it's a dog. You say, no, it's not a dog. Well, now the netizen has to enter a new question that distinguishes horse from dog. Does it have a mane? And that new question gets added onto the tree, and the tree grows this way. If everybody knew everything perfectly and there were no hostile people, this thing would work fine, and you get a very large database that would allow you to query things. Tell me any animals that have 2 legs and can fly, that don't have babies, whatever. But we want to ensure the quality of the data. We can't be sure everyone's going to be so good. So you have to be a little more subtle. So we want to correct these errors early so we don't build on a faulty node. Suppose there's a misspelled animal. You spelled horse H-O-R-S-Q or something like that. We only allow valid words from a lexicon of a precompiled lexicon of animal names, which we got off the web, actually. Only those can ever appear in the tree. Detection of questionable data or bug report. So suppose you go through this tree, you're playing it, and it comes out and says dog, and you say, wait a minute, I don't think a dog can swim, or there's something about the sequence of questions that you disagree with. Then you click a special button that locks that node and allows you to bring that bug report either to the domain specialist, the person who's doing this, or to the next player of the game and say, you know, can a dog really swim? If 2 more people then override it, then the node gets unlocked and continues. So there's a special notice that goes to the domain expert who arbitrates and chooses. Or suppose you try to submit an animal that's already one of the leaf nodes in the tree. So you're trying to put in horse here. You're trying to put in horse here, but horse already exists somewhere else. That means there must be a node for which one person answered no to, and the other person answered yes to. There's an incompatibility. There's something wrong. When you try and do that, it locks both nodes and basically makes a notice to the next netizen to arbitrate. Can a horse does it have 2 legs? Yes or no? And then it will unlock one and throw away the other. Oh, and then there's some raw software things about submission collisions. 2 people try and get to the same node and try and update it at the same time, and we just have You know, the first person gets 30 seconds to do it and so forth. I mentioned game theory. What we want is to seek a strategy to reward and teach netizens to give good data. But good depends upon the state of the classifier. Early on, we don't know really what is a 4 and what is a 9. And so even the strategy may have to change over time. Also, the adversaries may learn too. And so there's a competition, you know, it's a game theoretic problem. I talked about this problem of general data voting, but let me just go one level deeper and to analyze it. So I'm going to take this pattern, same pattern, and present it to k different netizens, and only accept their answer if all k agree, or the majority of k agree. Well, if I make k really large and everyone agrees, then I know this really is that category, and I'm really sure. But I've wasted so many inputs. I've wasted all your clicks. I might not need to get 100 people to agree before I'll accept it. So if k is large, I'll get a small amount of reliable data. And if k is small, I only ask 2 people or 1 person, I may get a large amount of unreliable data. Which is the optimal choice of k so that I improve my classifier? That's what I want most. Likewise, estimating netizen reliability. So the goal is to find an optimal k star for different reliabilities, the state of the classifier, the inherent Bayes error, and things like that. That's an unsolved problem. I'm working on it, but I think other people should work on it too. Or the analogous notion of catch trials, where I'm going to present a really well-known pattern to you once every Q pattern presentations, and only accept your data if you get it right. If I make k small, I get a small amount of reliable data, but if Q is large, I get a large amount of unreliable data. What's the optimal Q star? I'll skip this one, on exploratory learning or interactive learning. Sensitivity analysis, if I have a 2 Gaussian classifier system, and I can present just one pattern to you for labeling, should I put it somewhere here or somewhere here? In short, a sensitivity analysis. Which pattern, if labeled, would give me the most information for my ultimate classifier? So now I get to the political slide, the one my fingers were trembling when I typed it, you know, a year and a half ago, but now I fully believe it. And that is, Open Mind is inevitable. The need for this software is here. The web infrastructure is here. I would claim theory is here for a wide range of problems. Network, computer power, and memory are here. There's no problem there. So there's all this information in netizens' minds, and there's all these intelligent systems we want to build. And Open Mind is that framework. No doubt there are going to be details that I've outlined here that will prove to be wrong. People don't care about frequent flyer miles. They just want to see their name in lights or whatever. Nevertheless, there's got to be some route for extracting information over, contributed information over the web. So as I say, this collaboration is going to happen. It is happening. But I would also point out that I think it's less radical than Richard Stallman or Linus Torvalds. Richard Stallman, in 1983, a superb programmer, one of the best software engineers alive, really. He could have gotten a job anywhere he wanted in any corporation. And he said, no, I'm going to write software and give it away for free. And that was really radical when he did that. But the Free Software Foundation has been going strong and has made some really great software. Or Linus Torvald, I think he was 26 at the time, grad student that, you know, started the Linux project. So here are the take-home messages in conclusion. I think we're in an era of large data sets. Ha, ha, ha. I'm surprised. I know I'm shocking you here. And it's needed for further progress in a large range of problems. Open software development has led to high-quality software. There are whole industries of Linux out there, for instance. But open software allows you to integrate components more easily. And the novelty, so to speak, is that it can be used for many projects in pattern recognition, AI, and those kinds of things. That netizens can contribute large amounts of, I'll call it informal data. And there are some interesting opportunities for development in algorithms and theory. So the status is we've got the Open Mind, www.openmind.org website up. We had to buy that from a radical gay and lesbian society that wanted you to be more open-minded about your sexual preferences. We've got that lovely logo was donated by ImageWorks. The home, and we have a project page donated by Diamond Bullet Designs. We have a public relations firm that's donating their time. Ruderfin, an international company, we're very thankful for all this. We're working with legal counsel on exactly some of the license issues. I don't want to get into that right now, maybe in questions if you're interested. We've gotten people willing to donate books and CDs and things like that. We're just don't know where to store them and who pays for shipping because we can't afford to ship them right now and things like that. We've got some demonstration projects and got the 3 projects up and several infrastructure developers that are donating some amount of time. Go to our website and get on our mailing list if you want to find out more. So with that, I'd like to say that the Open Mind is this collaborative framework for developing intelligent software. I've told you about the domain experts, the tool developers, and the netizens. I've provided some vision, I hope, of the future. And with that, I will thank you very much for your attention and take any questions. Thanks very much. No doubt there are questions. Yeah.
Seems like there's a lot of pressure in academia not to release source code. This is my impression.
Really? I don't get that.
Like a second review.
Well, I try to put pressure on people to release source code.
There. No, I think it's certainly more prevalent now than it was 10 years ago. And I think.
Well, just in general, like not just here. Like, of course, Sundance. I mean,
I'm sorry?
There are growing pressures to universities not to worry about intellectual property very, very careful.
Well, MIT is doing this, and they have I mean, they would be worried, but aren't. So, or at least they've signed off on it. So I think there's more, there are more data sets, and even just graduate students taking algorithms and papers that are public knowledge. There's no problem about doing this and implementing those as far as I know. So I think there's more and more of this going on, but we'll see. Yeah.
So to some extent, the talk you've just given is along the lines of one of the free software manifestos or the Cathedral of the Bazaar or something. Whereas in some ways, what's been especially useful about the early projects in open source is that they've shown us the way to do things, and more important, that they've inspired tools like the SourceForge website, which says, look, if you want to start an open source project, here's all the stuff you need to get going.
Yeah,
So here's the scenario that I'm thinking about specifically. Suppose I'm not doing research in machine translation. Suppose I actually have a tool which does translation, which helps people do machine-assisted translation. So it'll do a crude translation, and then the people correct it rather. So I'd like to collect the corrections.
Yeah. That could.
I'd like to team up, or people in academia would like to team up with me so that I can arrange for them to get the corrected text produced with my machine.
All that could be done through this, so long as and we're crafting the licenses right now. Exactly what. Basically.
So what are the tools and what are the licenses that are there for reuse? You're right. Licenses are also something that can be given.
Yeah. There are open source tools that we're using for things like databases and things like that. But the things that are being developed and we have to work on are the things like the data voting. That's a typical tool that you might want to use in many different things. So there'd be the data voting module that you could use for speech and he could use for OCR and she could use for something else. So that's the kind of stuff that we know will be built up. And also tools for navigating databases. We want to have as much consistency and coherency so that the same kind of tool will allow you to find, grab and download data, 1 year's worth of data or the last month's worth of data and other kinds of restrictions on your choice of data. So all that kind of stuff is what the tool and infrastructure developers have to develop, and it's just getting going.
So what kind of data will you really solicit?
What kind of data will I?
Really solicit?
Solicit. Well, I showed you the handwriting stuff that we're really soliciting that. The common sense stuff project is soliciting simple assertions about the world. Just, utter simple sense.
How is it going about it?
Go to www.openmind.org/common-sense, sign in, and just contribute data. One thing.
Why should I?
Let me go back.
You don't get me. if I was in the habit of going through the internet and wasting my time or whatever, I would do it, but it would never occur to me.
Oh,
There or
oh, sure. No, the PR has not been turned on yet. We have not really announced this to the public. We're going to the New York Times, we hope, at a big conference in January. So the public, for the time being, it's mainly university people and corporations that I've been speaking to that have come to our website. But we hope to get large numbers. If you announce on Slashdot and big public forums, we think we're going to get lots of people. So once they get going, and we have some incentives, different incentives in place, we hope to keep them and keep it interesting. So, and you might not be interested in common sense. We don't expect everybody to be interested in every project, but if there were a speech project being done here or a bracketing project, you might be really interested in contributing. Yeah.
Do you have any plans for a world model of users who contribute? I mean, I was just thinking, I was reading about the way the word hotel is used around the world. Here in this country, it's hotel. Elsewhere, it's bar, other places, it's restaurant. If you're not keeping track of where people are responding.
Yeah. No, yes, that's something I was talking to Doug Lennett about down at the Psych Project. Common sense about stores, for instance. In America, we have stores that basically are focused on individual rooms in your house. If you want something for your bathroom, you will be able to buy toothbrush and toothpaste and maybe a cup and all the kinds of things that go in your bathroom. Whereas in Europe, you might go to a store that is just for porcelain things. And so you get the same kind of porcelain thing that would go in a bathroom or a kitchen or outside and so forth. And so you have different ways of chopping up the world. Yes, and I think a good example of how we should monitor individual kind of users is things like pronunciation, accents, Southern accents, and Northeast accents, or European accents, or whatever. And of course, this will depend upon the individual project domain. I mean, what happens in OCR? I mean, it's fairly simple. The differences might be that you cross a 7 in Europe and not in America. I can't be any more specific than that, but except to say that the domain specialist could could monitor that if he or she thinks that's part of the the background, and then gender and so forth. Women like this kind of phrase structure, men like this, or whatever it is. Other questions? Yeah.
So I just want to come back to the example I gave before about software which is intended to do a task, where people, through no altruistic mode, might have to correct the output if the machine does it imperfectly. It seems to me like that's an important source of data, but it's rather difficult to get because people are doing it using other people's software. You have to negotiate the motivation of the people providing the software, and if I hook up my OCR system to Microsoft Word, then OCR is coming in. I have to hook up the handwriting data from the OCR with the corrections in Word, and somehow separate the corrections.
Well, we would want the corrections to be done in a interface that's part of Open Mind, so that it gets transcribed here, and as you correct and click it before you export it, we now have access to that data. So here's another way you could do it. For instance, you download a speech recognizer that you use for a week, and only at the end of the week, the corrections or the cumulative changes in the parameters get sent back to the Open Mind site. So you're using it on whatever speaker you have on your own desktop machine. So there are different models, there are different ways in which you'd be able to collect the corrections that people use. And to the extent that people will use the Open Mind software, you don't have to worry that they're importing it to Microsoft Word or Excel or something like that. Am I getting it right? Or
well, so in a sense, you're figuring that all of the software that people are using to produce the data you're getting was written by you, and that seems like it might be foregoing a chance to use other people's software to collect data. I mean, I understand the attraction of saying we're going to use the Open Mind speech recognition software, but it's going to take a while before it catches on.
Yeah, well, one thing I mean, here, let me rephrase your question. In other words, you use via voice, and you've trained all that. Now we'd like to take those parameters from via voice and use them somehow in Open Mind. People don't, whatever. Well, I mean, you're using a third-party software and using their, the learning or the feedback from that, or the corrections from that, and there may be legal problems with that. Via voice, or the proprietor may claim that we have taken advantage of them.
Yes, I was asking, would you be interested in pursuing agreements with via voice companies?
I'll have to think about. It's too early. I'll have to think about that. I mean, I wouldn't rule it out, but especially if we could show that our data is, or they alter their system so that it's works better with Open Mind, Open Mind inside instead of Intel inside, so that they use our parameters in their things and our data formats, for instance, or we use one of theirs.
Sure. And they get something out of it because they get within that.
Yeah, exactly. We have to think about these. Yeah. So with that, I'll stick around for individual questions, but thanks again very much for coming. No.